Hey everyone, welcome back to this final video for topic 5 in our database class, part 8. And in this video, I'm going to discuss how we can implement and use recursive relationships in real world databases. Let's get started. And this will be a little mind bending, particularly when we take a look at the SQL statements for it. But remember that conceptually, a recursive relationship is when a table is connected to itself. Okay? So we want to have the ability to have tables that are related to themselves. And we need to see how to model that and how to write SQL statements that will allow us to support that type of design. And so recursive relationships can be one-to-one, one-to-many, or conceptually they can be many-to-many. But as we will see, if we have a recursive relationship that is conceptually many-to-many, we will need to create an intersection table to implement that, just like we have to create an intersection table to implement a many-to-many relationship between two tables. Okay, so in this case, it's a many-to-many conceptually connected to itself, but we're going to need a second table to implement that as an intersection table. So let's see how these work. These are interesting and weird. Here are some very simple conceptual ERDs that illustrate what's happening. Okay. So here we have a sponsorship relationship. Okay, so sometimes certain places like clubs or like a country club or whatever, they might have some kind of sponsorship relationship where each member of the club is allowed to sponsor one other person to join the club. Okay, so you can't just go and join if you want to. You have to be sponsored by an existing member, and that person is only allowed to sponsor one other person. So in that case, we would have this recursive one-to-one relationship. It's a sponsorship relationship. Each person can sponsor at most one other person. Here we see a one-to-many recursive relationship. This is a referral relationship in this case, this example, and that's very common. Maybe you've seen some of these things like, hey, if you refer your friends, for every friend that you refer, we'll give you a $5 discount on your next bill or something like that. Okay, so each customer can refer potentially many other customers to the company. Okay, but each customer is referred by at most one other customer. So this is a one-to-many recursive relationship. And then again, this is conceptual, but here's a conceptual many-to-many. In this case, it's a treatment relationship among doctors. So physicians in this case, right? And we know that if you are a medical doctor, then you also need to receive medical care, and that care will be received by or received from other medical doctors. So a doctor can treat other medical doctors, and each doctor can be treated by many other doctors. So this conceptually is a recursive many-to-many relationship. But do keep in mind the important fact that these are conceptual. This cannot be implemented directly. This conceptual many-to-many cannot be implemented directly, just like a many-to-many binary relationship cannot be implemented directly in a real-world database. We're going to need to add an intersection table to implement this. These two, however, the recursive one-to-one and the recursive one-to-many, can be implemented directly. And let's see how we do that. Okay. So here is a physical recursive relationship. And in the upper left, we're looking at a one-to-many recursive or a one-to-one recursive relationship. So this was our sponsorship relationship. Okay. And again, the idea here is that we're going to add an additional attribute to the table. And we need to keep in mind that this ID value is a person ID. Okay? So a sponsored by ID in this example is going to be populated with person IDs, or it may be null. In this case, we allow null values, so the possibility exists for this to be null. Okay? Which would mean that a person is, I don't know, say like a member of our club, and they were not sponsored by anyone. Maybe they're like a founding member of the club, so they don't have a sponsor, right? In that case, their sponsored by ID would be null, but in all other cases, there would be a value for this attribute, and that would be a person ID. All right. So one-to-one recursive is illustrated there. Very easy to implement. We just add an extra attribute that serves as a foreign key link to the same table. In this case, it is connecting us to a person ID in another row within the same table. And so if I'm looking at, I don't know, like row number 7, sponsored by ID might be for the person located in row number 1. So it's just pointing to another row within the same table. All right. Now in the upper right, over here, we see a recursive one-to-many relationship where each row in the table is potentially related to many other rows within the same table. Okay. In this case, we can see it's an optional many, 0 to many. And of course, that means that we have to allow null values in our foreign key, meaning that this is a customer and referral kind of relationship that we're modeling here. So it's possible for us to have a customer that was not referred by another customer. But with this design, each customer could potentially refer many other customers to our company. So let's say that customer number 1 has referred 3 of her friends. So maybe customer number 1 refers friends 2, 3, and 4. So for customer IDs 2, 3, and 4, for those rows in the table, the value of referred by ID would be 1. Okay. So that customer ID, number 1, would appear here multiple times in the table, because it's a many. Right? So this is how we do a recursive one-to-many. Conceptually, the design is the same as a recursive one-to-one. We just add another attribute to the table. It serves as a foreign key link to the same table. It just points to other rows within the same table. Now, finally, down here at the bottom, we see an implementation of a conceptual recursive many-to-many relationship. This is where a doctor can treat other doctors. Okay, so a doctor can treat other doctors, and each doctor can be treated by many other doctors. So it's conceptually many-to-many. So what we have here conceptually is something that looks like this. The table is related to itself in a many-to-many relationship, but we can't implement that directly. To implement it, just like when we have a conceptual many-to-many in a binary relationship, we need to add another table. So we add this intersection table, and in this case, we're calling this doctor-patient, and we're using this to keep track of which doctors are treating which other doctors. But the doctor who is receiving the treatment takes on the role of patient. So we record that as a patient ID. But the point to make here is that patient IDs in this design are doctor IDs, right? So the values stored in this attribute will be doctor IDs. It's just, is that person playing the doctor or the patient in the relationship? Now you'll note that we have 2 relationship lines. So these tables are doubly related to each other. Interesting. Right. So a doctor ID can point to this doctor ID over here in this table if the doctor is playing the role of doctor, that is, if they are providing the care, but that doctor ID may also appear in this table as a patient ID if the doctor is receiving the care. So the table is doubly related, right? We have a connection between doctor ID here and another connection from doctor ID to patient ID here. So I know this is a little weird, but maybe if we take a look at it from a data perspective, it will make a little more sense. So here's our first example. This is a one-to-one sponsorship example where each person can sponsor at most one other person. say, to be a member of our exclusive little club. Now we see this from a data perspective. Up here at the top, we can see how this is arranged. Right? Here's our person ID. And you can see we have 5 people in this example, persons 1, 2, 3, 4, down through 5. And we just have some last names in here to fill out the example a little bit. And then we have a sponsored by ID here. So these first 2 are null, indicating that these 2 people did not have a sponsor. And for the remaining 3 rows, we see that persons 3, 4, and 5 do have a sponsor. And their sponsors are persons 5, 2, and 1, respectively. Okay. So again, each row is potentially related to one other row in the same table. So if I'm looking at person number 3 and I say, who sponsored person number 3? Well, I see that was person number 5. And then I can say, okay, here's person number 5. So that's Smith. So Smith is the sponsor for Parks, right? 3 was sponsored by 5. Similarly, person number 4 was Pines, was sponsored by person number 2. So I can follow this back to another row within the same table, and I can see that Pines was sponsored by Myrtle, who in turn was sponsored by no one. Maybe they're a founding member of the club. And finally, I can see person number 5 is Smith, who was sponsored by person number 1. So I can trace that back to another row within the same table, and I can then see Smith was sponsored by Jones, who was sponsored by no one. Now let's take a look at the sequel for this. And this is going to be a little weird because we're going to have to select data from 2 copies of the same table. So here we're doing it in the where clause. We're doing an inner join. So note that we have 2 copies of the person table that we're pulling data from. One of them we're referring to as A. So that's copy number 1 of the person table. And the other one we're referring to as B. That's copy number 2 of the person table. And then in the select statement, we're getting the person value out of table A. That's our first copy of the table. And we're getting the person value out of table B. It's our second copy of the table, but we're going to refer to that as sponsored by. And then we do the join based on matching values of sponsored by ID matching the corresponding person ID. And this would generate output that looks like this. Note that this is an inner join, so the null values are not included. Those rows where the sponsored by ID is null are not included. And if we see how this looks, you'll see that it makes sense, right? So here is person Sparks, and we see they are sponsored by person Smith. And if we take a look back up at the data, here's Parks. Parks is sponsored by person 5. And if I look at row or person number 5, I see that's Smith. Okay, so Parks is sponsored by Smith. Similarly, Pines is sponsored by person number 2. Person number 2 is Myrtle. And that's what we see illustrated down here. Pines sponsored by Myrtle. Same thing with Smith and Jones, right? So a recursive relationship, in this case, a 1-to-1, table is related to itself. Each row just points to potentially one other row in the same table. And we have to be a little creative with our SQL statements by pulling data out of 2 copies of the same table and then joining the table to itself based on matching values of these 2 columns. Curious. Let's see a one-to-many. So here's our one-to-many recursive relationship. This was our referral relationship, where we allow each customer to potentially refer many other customers to us. So we created this referred by ID in order to keep track of these relationships in the same customer table. And we just know that a referred by ID is a customer ID. Okay, so if I look at Leonard, I can say, who referred Leonard to us? Well, that was customer number 2. And then I can look at customer number 2 and say, okay, Leonard was referred by Sheldon. But this is a recursive one-to-many, so it's possible for Sheldon to refer multiple people, multiple customers. And we see that, right? This person down here, Amy, was also referred by Sheldon. So Amy was referred by Sheldon, and Leonard was also referred by Sheldon. They have the same customer ID over here as a referred by ID, right? The same is true of Leonard, right? We can see that Leonard referred these 3 customers to us. Penny, Rajesh, and Howard were all referred by Leonard. And then we can see Bernadette was referred by Howard, and Sheldon wasn't referred by anybody. So this is a recursive one-to-many, because in this case, each customer can potentially refer many other customers to us. Now, the SQL syntax is the same as we just saw previously for the one-to-one recursive relationship. We just need to select data from 2 copies of the same table, right? And we link those tables together based on matching values of, in this example, customer ID and referred by ID from the 2 tables, 2 copies of the same table. And that yields this kind of output over here. Now, this is an inner join. So Sheldon does not appear in our list here, because with an inner join to be included, Sheldon's referred by ID could not be null. Right? It would have to be another person in the same table. Here's how we do this recursive relationship using the join syntax in the from clause, right? So here I'm using join instead of using the where like I did previously. But other than that, it's identical. They'll produce identical results. Okay, so graphically, or I mean in a data format, then we can see, okay, Leonard was referred by Sheldon. Amy was also referred by Sheldon. Penny, Rajesh, and Howard were all referred by Leonard. And Bernadette was referred by Howard. So it's interesting. You can see the layers in here, right? Howard was referred by Leonard. Bernadette was referred by Howard. Let me see if I can trace this backwards. Okay, so Howard refers Bernadette. Leonard refers Howard, and Sheldon refers Leonard. So Sheldon refers Leonard, who later refers Howard, who later refers Bernadette. All that information is encoded in this table. So it's interesting. We have layers of referral in here, like multiple levels of referral. But again, it's just the idea from a SQL perspective is we need to pull data from 2 copies of the same table. All right, and then finally, we have our recursive many-to-many. And remember, to implement that, we had to create a second table. We had to add a second table to the design to serve as an intersection table or a lookup table. And we use that table as shown or as illustrated here to hold information about the relationships between doctors. That is, in that relationship, which doctor is providing the care and which is receiving the care. If they're receiving the care, we refer to them as a patient, even though they are actually a doctor. If they're providing the care, we refer to them as a doctor in this table. That way we can keep track of who is providing care to whom, despite the fact that they are all doctors. Okay, so we use this table to serve as a lookup table that lets us keep track of these various relationships. And if we wanted to sort things out, we would say, okay, so here's Dr. Abernathy, and Dr. Abernathy has Dr. Jones as her patient. Okay. But Dr. Jones, who is doctor number 3, has Abernathy as her patient and Dr. Smith as another patient. Okay. So we have these weird many-to-many relationships in here. Now, in this case, the SQL is a little more elaborate because we have to remember that what we have here is 2 relationship lines between these. So to join these together, we're going to need 2 copies of this table and 1 copy of this table. So it's actually a 3-table join, even though there are only 2 tables involved. You can see that here in the from. We have 1 copy of the doctor table that we're referring to as A, a second copy of that same table that we're referring to as B, and then we have our doctor-patient table in there that we're referring to as C. And in this case, we're doing the inner join and the where clause. So we link them together based on matching values. So doctor ID in the first copy of the doctor table connects to doctor IDs over here in our doctor-patient table. Right, so we have these relationships. And then we have in our second connection, doctor IDs here in the doctor table that connect to patient IDs over here in our doctor-patient table. So 3-table join involving 2 tables. It's just that we have 2 copies of the parent table there. And this produces output like what we see here. Okay, so we can now see that Dr. Abernathy treats Dr. Jones. But Dr. Abernathy is treated by Doctors Franklin, Jones, and Smith. And we could do the same for any of the other doctors. So Dr. Jones treats Dr. Smith, right? Dr. Smith is treated by Doctors Jones and Parks. So curious. All right, I know it's a little weird, a little mind-bending, takes a little practice, but hopefully you can imagine many different scenarios where this type of design can be exceedingly useful, can simplify the structural complexity of the database greatly.